Welcome to the Module 2 of the course Introduction to Mobile Robotics. In this module, we will study perception in mobile robots, which is the ability of a robot to sense and understand its environment. We will discuss the role of sensors, sensing principles, signal conditioning, sensor interfacing, and calibration. These concepts form the foundation for robot navigation, obstacle detection, and intelligent decision making. Perception. Perception is one of the most important tasks of an autonomous mobile robot. It refers to the ability of the robot to acquire knowledge from its environment. Perception involves taking measurements using various sensors and extracting meaningful information from those measurements. This information is essential for tasks such as navigation, obstacle detection, localization, and decision making. Without perception, a mobile robot cannot interact intelligently with its surroundings. Here it shows a block diagram of a typical mobile robotics where it has four different phases. One is localization, followed by the perception, and the other two blocks are the cognition and the motion path control. The flow is such that from the localization, where the position is determined and it is fed to the cognition block. From the cognition block, the path is designed or determined and it is fed to the motion control where the movements will happen. From the motion control, the data will be sent through the real world environment to perception and it is again fed back to localization. Next is the sensors. Sensors are devices that convert physical variables into electrical signals. Just like human beings use eyes, ears, nose, and skin to gather information from the environment, robots use sensor to perceive their surroundings. A sensor is used to measure a physical quantity such as distance, temperature, light, or gas concentration. Sensors require calibration to ensure accuracy and they play a vital role in building intelligent and autonomous robots. Now we'll see the typical block diagram of a perception plus sensors state. This block diagram shows the basic flow of sensor data in a mobile robot. A physical quantity from the environment is first sensed by the sensor, which converts it into an electrical signal. This signal is then processed by a signal conditioning unit to improve its quality. The conditioned signal is converted into digital form using an ADC, that is an analog to digital converter, and sent to the microcontroller or the processor. Based on this data, the robot makes the decision and performs appropriate control of actuation. Next, an important part that has to be carried out is the signal conditioning. Signal conditioning is the process of modifying sensor output signals to make them suitable for further processing. Sensor outputs are usually low in amplitude, affected by noise, and may have offset or non-linear characteristics. Signal conditioning improves accuracy, reliability, and compatibility with ADCs and controllers. Therefore, it is a critical step in sensor data processing. Why do we need a signal conditioning circuit? Signal conditioning is required for several important reasons. It amplifies the weak sensor signal so they can be detected properly. It removes noise and interference present in the signal. It ensures that the sensor output range matches the input range of the analog to digital converters. Signal conditioning also protects processing circuits from high voltages and improves overall signal stability and resolution. Next is the different steps to be carried out while performing the signal conditioning process. The signal conditioning involves several operations. The first is the amplification, which increases the amplitude of low-level sensor signal and is commonly implemented using operational amplifiers. The filters, which is the second step, removes the unwanted frequency component such as noise. The third step is the level shifting, which adjusts the signal voltage to the required range. For example, converting a plus or minus 5-volt signal to a 0 to 5 volt range. The last step is the signal linearization, in which it corrects the non-linear sensor characteristics, thereby improving the measurement accuracy. Which are the different components that can be used in the signal conditioning process? We have a various electronic components that can be used for this purpose. Operation amplifiers are the main important component that is used for amplification, filtering, and buffering. Instrumentation amplifiers provide high accuracy and high common mode noise rejection. Filters can be active or passive and are used to remove noise. Analog to digital converters convert the conditioned analog signal into digital form for processing by controllers. Next is the sensor interfacing. Sensor interfacing is the process of connecting a sensor to a microcontroller or a processor so that the sensed physical quantity can be read and processed. The main purpose of the sensor interfacing is to transfer the sensor output accurately and to convert the analog signals into digital form, and finally to ensure compatibility between the sensor and the controller. Sensors may provide analog outputs which require ADCs or digital outputs which can be read directly. Examples of analog output sensors include the temperature sensors, gas sensor, IR sensor, etc. And for digital outputs, the examples are ultrasonic sensors, encoders, and inertial memory measurement unit. Next, we will see the common interfacing methods. There are several commonly used sensor interfacing methods in mobile robotics. The first one is the analog to digital converters, where the analog data are converted to digital data and we have several analog sensors performing the same function. Next is the I2C, which is a two-way communication protocol widely used for digital sensors and the inertial measurement unit. Next is the SPI, which is a high-speed serial communication portal. And finally, we have the UART, which is used for serial data communication. Proper interfacing enables reliable perception, real-time data acquisition, and supports navigation and obstacle detection. Next, we'll see an important term that is being used in the field of robotics, that is sensor calibration. Sensor calibration is the process of adjusting sensor outputs so that it accurately represents the true value of the measured physical quantity. Calibration is necessary because the sensors suffer from errors such as offset, grain variation, drift due to temperature or aging, and nonlinearity. Calibration helps correct these errors and improves sensor accuracy. What are the steps involved in the calibration process? The first is a known reference input is applied to the sensor. The sensor output is then measured and compared with the true value. Correction factors are determined based on this comparison. These corrections are applied either in hardware or software to obtain the accurate sensor readings. Next, we will see what are the types of calibration. First is the factory calibration, which is performed during manufacturing process. Next, we have the field calibration, which is done during actual usage. We also have the static calibration, which uses a constant input values and see how much the outputs are varying. While dynamic calibration is another type of calibration which uses time varying inputs. The type of calibration chosen depends on the application and the operating conditions. What are the benefits of calibration? Sensor calibration offers several important benefits. It improves measurement accuracy, ensures repeatability and consistency, reduces systematic errors, and enhances the reliability of robot perception. Proper calibration is essential for accurate sensing and effective decision making in mobile robotics.